So here we're going to use the estimation theorem to estimate the value of this absolute value of this integral. Now we've got C, which is a contour joining I to 1, and what we've got here is the integral of 1 over z to the 4 along that straight line contour. So using the estimation theorem, what we do is we set out our basic building block for that. So the absolute value of some integral of f of z dz and its absolute value, that's less than or equal to, now we need two constants here, m and l. So this is sometimes known as the ml inequality. Now m is the maximum value of f of z on this straight line contour. So if I do absolute value of f of z, what that is going to be is less than or equal to some value m. So this basically be the maximum value of this absolute value of the function. In this case here, f of z is 1 over z to the 4. So that's what we got there. Then we need to find L. Now L is just the length of the contour. So L is the length of the contour. So sometimes we can use gamma, sometimes we use C. In complex analysis, they both work the same, it's just a letter to represent it. Now the length of the contour from I to 1, that's going to be reasonably straightforward to draw. So let's just represent it on our graph. So I is going to be about here, 1 is going to be about here. So joining I to 1 of a straight line, and we want to find the length of that. Well, if that's absolute value of 1, and that's also absolute value of 1, that's going to give us square root of 2. So straight away we can see that the length of C, that is going to be square root of 2. So we've already got our L value. Now we need to find M, which is the maximum value of f of z, but on this contour. So as we've got a reciprocal function, what we want to try and do here is find the minimum value of z as it's in the denominator. Now where's the minimum value of z on here in terms of its absolute value? Well, that's going to be the shortest distance from our origin. So in this case, if I take the normal from there, here I've got a midpoint of a line here. Now a midpoint, in this case from I to 1, so the midpoint, not to be confused with this m, so our midpoint, if I write that like that, that would just simply be half of our real and imaginary. In this case it's 1 plus I. So that's the midpoint there. And that would give us the value of our minimum value for this point on the straight line contour. So with that, if you've got the minimum value and put it in the denominator, that's then going to give us our maximum value for our f of z. So let's do that. So if I put this in here for our z and then calculate it. So let's find this one here. So minimum value, let's write it here. So m equals 1 over, then I've got this to the power of 4. So I've got a half times 1 plus I all to the power of 4. So that's our minimum value. And obviously I need that in our modulus. So this is now, just rewrite that to make it easy to work with. So then I've got 1 over a half plus I over 2 all to the power of 4. So what I need to do now is use our Pythagoras' theorem for this. So I've got a half plus a half and then square each one and take the square root. So then I've got, because we've got our modulus here, so I've got square root of a half squared plus, in this case as well, using I, I've also got a half squared. So let's just write it like that. So then basically I've got a square root of 1/4 plus a quarter, which basically equals the square root of a half. So the square root of a half, that's the same as 1 over root 2. So now I can substitute that into here, 1 over root 2 to the power of 4. So then I've got my absolute value of 1 over 1 plus root 2, and then just put that in that bracket there, all to the power of 4. Now if I raise this to the power of 4, I'm going to end up with root 2 squared is 2, and then square it again, it's 4. So I've got 1 over a quarter. So then that becomes the absolute value of 4 over 1. So that'd be that simplified. So now using our ML inequality, what I can say is here now, m times L, let's just write that here. So m times L is, well, I've got 4 times root 2, which is just 4 root 2. So in which case now, estimating this, that's going to be less than or equal to ML, which is 4 root 2. That is going to be our answer. Now, one thing we just need to just check on just before we go is this 1 over z to the 4, is that a continuous function, and would it ever reach 0 on our contour? Now we can see here that it's never going to reach 0, and it is a continuous function as well, 1 over z to the 4. So our result here is valid. So our result here for our estimate of this integral is 4 root 2. Okay.